Hi, I'm Instructor Gregory and welcome back to Module 9 of Networking Fundamentals. Right now we're going to talk about wide area networks, alright? So let's take a quick look at our agenda. We're going to cover two different objectives today. We're going to talk about routers and how they work. Well, more specifically, static and dynamic routes. So the path that data take to get across the internet or across networks, okay? And then we're going to talk a little bit more in depth about wide area networks. First off, the router, right? So what is it? What does it do? It's just a central connecting device that uses TCP/IP routing protocols to forward packets. They use IP addresses like we discussed, a layer 3 protocol, right? IP. And routers connect local area networks to each other, and they allow communication between hosts on different networks. Routers have routing tables, and they use information in these routing tables to make educated decisions about how we route from one host to another, right? So we send data across a network or wide area network, as we're going to learn in a little bit. But routing tables, they contain just a list of paths to various networks, right? And they can be configured manually or automatically. Now, when configured manually, it's known as static routing, and automatically is known as dynamic routing. Alright, so I have an example here of a static routing, right? And what's going to happen is every single time when you send data from your device here to this server over here, it's going to follow the same exact route, right? Now, the server, when it sends back data, it may not necessarily do that, or may be configured for dynamic routing and not static routing. So keep that in mind. Static route clearly just has a fixed path. I really want to emphasize that right now. It's definitely a very, very fixed path. So data is always going to travel down a fixed path. One thing that is really important to know about static routing is that if any links or any hops happen to go down, when that happens, you cannot send data to that destination anymore. The route is simply unavailable, and that means it's not fault tolerant, right? Which can definitely cause some problems, okay? So keep that in mind, and let's move forward with dynamic routing. With dynamic routers, routes change, right? Dynamic routing allows for a router to detect when brand new routers are connected, and this means new pathways are available, right, for sending packets. And so routers then add it to the routing tables dynamically, right? And so it's automatically updated. And that's what dynamic means, right? Automatic. It just adjusts. Now, this type of routing is fault tolerant, because what happens is if a connection goes down, maybe you have like 3 connections that goes down, right? Well, guess what? I can still send my data down a pathway to the server. So dynamic routing is super helpful. Always aware of the best place for us to send our data when moving from router to router, and ensures efficiency, fault tolerance, right? And just effectiveness of the internet as a whole. Dynamic configuration of the routing table is not possible without protocols, right? And protocols, of course, are our favorite things because they make sure that the internet functions, right? And there are a few different protocols that you need to be aware of for dynamic routing. So you have RIP, Routing Information Protocol, and then there's OSPF, Open Shortest Path First. It's a protocol that monitors a network for routers, and it will adjust the routing table based on when the link state of a router goes on to off or off to on and so on, right? And it's aware of these devices that are on the network, right? And then you have IGRP. This is your Interior Gateway Routing Protocol. And you also have the Border Gateway Protocol as well. Now, I want you to definitely do a little bit of research on each of these protocols, and know that these are things called distance factors that you should be aware of, right? And it's just a calculation and essentially a metrics that's used to determine which route should be used to send packets. Just a real quick review on the routing tables in larger networks. Storing information in routing tables require a lot of memory. And so the more and more entries means the more memory. And the number of entries sort of dictate how routers and routing protocols are used, or rather which ones are used, right? So there's a lot of factors that will go into how we set up routing on our networks. All right, so let's talk about wide area networks and what they are, right? So first off, the internet is a wide area network, right? Wide area networks are just multiple local area networks over a large geographic region. And so what you're going to see here on the slide is that you might have routers that sit at the edge of each of these local area networks, right? And may be connected and meshed in order to make sure that each of these local area networks are able to communicate. And of course, those routers will be able to connect to our switches. Now again, the internet is the largest wide area network in the world. All right, so the internet in general, right? Local area networks, wide area networks, they use a technology called packet switching. And packet switching means that data is broken into small segments and then addressed. And addressing information is added to each segment in order to make it a packet. And then from there, routers transmit packets across networks from one local area network to another, right? Now, when packets arrive at their destination, they're simply reassembled by walking through the communication subnetwork in the OSI model, and then they're reassembled into the wonderful, beautiful images and data that we see on our screen. All right, so let's talk about different kinds of connection technologies that are available on a wide area network, right? So how do we access the internet from our home or from our office, What kind of technologies are available to help us connect all that data out there, right? So the first step is T-carriers, and a T-carrier is a telecommunications carrier, right? It's simply a cabling systems that transfer data at high speeds, right? And it's a dedicated line, right? So if you have a line from a T-carrier, you're going to have some pretty high transfer speeds, right? Now, there are two common carriers. You have your T1, which is also known as E1 in Europe and J1 in Japan. And then you have your T3, which is known as E3 in Europe and a J3 in Japan, respectively, right? These are private lines between local area networks, and sometimes you may find different offices using T-carrier systems. All right, up next is ISDN, and that stands for Integrated Service Digital Network. ISDN is just a digital technology that's developed to offer faster communication speeds than the analog telephone line, right? So telephone lines, of course, if you ever had a dial-up modem, they weren't very fast, and that resulted in just painful download speeds, right? But it's just that. ISDN is a set of communication standards that enable simultaneous digital transmission of data, like your fax, your voice, and your video. So another way of telling this is that it's a converged network because all of those services are offered on the same line. All right, up next is the Fiber Distributed Data Interface, or FDDI. All right, now it is a standard of transmitting data on fiber optic cables at a rate of around 100 megabits per second, right? Now, a cool thing about FDDI is that it supports transmission beyond 50 miles. Also, the original FDDI standard called for a physical double ring topology. So I have a little model for you here on the right, and I hope that helps you to envision it. Now, FDDI is primarily a protocol used on backbone networks. And something I think that is really interested is backbone networks in general, right? Period. That's where all the data is being sent across the internet at super high speeds, right? So the internet is a really complex system. And it got a very complex infrastructure, right? But the backbone is where things are being sent back and forth at its fastest rate. And that's why we can send ping and we can get it back in a millisecond, right? Or we can go ahead and send a DNS request across the globe and perhaps access a website in just nanoseconds, right? And it's absolutely insane how fast the internet can be and how fast networks are right now. All right, so next we're going to detail new communication technology, the digital subscriber line, or the DSL, right? This is just a family of technologies that provide data transmission using local telephone networks to do so. And so voice and data can run on the same line, right? Now, this uses a higher frequency band to transmit data. So you have three different varieties of DSL here. You have the XDSL, we've got ADSL, and then we have the SDSL. Make sure that you're aware of all these different varieties. Broadband cable is used for cable internet and cable television. And this is probably what you have in your home right now, right? I have it in my home. It operates at a higher speed than the DSL at a rate of about 384 kilobits per second to about 20 megabits per second, right? So that's pretty common, right? A common network speed for a home internet. So this is something that you're using right now, but you may not even realize it until right now because, well, I just told you. All right, so the last technology we're going to talk about is POTS, which is plain old telephone system, or the PSTN, which stands for Public Switch Telephone Network, right? So how many of you out there are still using the telephone system anymore, right? I have a cell phone, so I use a cellular network, right? But you know, the POT system is what we use for our phone lines, and that's actually been around since the 1940s. Now, this is now digital, but it used to be analog, and it also depended on something called a circuit switch technology. And we had a dedicated line. So if I pick up my house phone and call someone, and someone else in the house picked up another phone, what would that mean is that the person holding that other phone in the house will hear everything that I was talking about, right? With a friend or with a family member or even with a girlfriend. And that always leads to something really embarrassing. All right. Well, that's all I have for that subject matter. So POTS, plain old telephone system. All right, so let's review our agenda here. We talked about routers, right? And we discussed static and dynamic routing in general. We also touched on what wide area networks are, as well as some of the connection types that are featured in wide area networks that helps us to communicate. All right, so that's really all I've got for this module. I'll see you in the next and last one. Thank you for joining me, and take care.